Hi friends, today's topic name is CPU scheduling algorithms. In the CPU scheduling algorithm, the four different types of algorithms are there. First one is first come first serve, and next one is shortest job first. Next one is priority. Next one is round robin. These four are I will explain with the using of the examples. Example for first come first serve is like this. The first come first serve processor are the P1 process and P2 process and P3 process, and burst time 24 3 3. That means the P1 completed at 24 milliseconds, the P2 is completed 3 milliseconds, and P3 completed at 3 milliseconds. And when a process started in the first come first serve, that means the first come is P1, then it can be served. That means the process is started P1 at 0 seconds to 24 seconds, and next one is P1 started after complete the P1, then next after complete the P2, the P3 was started. That means the timings are 0 to 24, and next one 24 to 3. That means the value is added 24 plus 3, the value is 27. At 27 is P2 completed and P3 completed at 30 milliseconds. In this process, the P1 not wait for example, the P1 started at 0, he cannot wait the any process can complete it, but the P2 is wait up to completed the P1 process. The P1 process completed when 24 milliseconds. That means the P2 waiting time is 24, the P1 waiting time is 0. Similarly, the P3 is started or waiting up to completed of the P1 and P2. The P1 P2 completed at 27 milliseconds. That means the P3 is wait up to 27 milliseconds. Then after complete the 30 milliseconds. The waiting time like P1 is 0 and P2 is 24, the P3 is 27. So similarly, we calculate the average waiting time for the values of P1, P2, P3. The average is nothing but P1 plus P2 plus P3 by 3. The number of what is the waiting time of individual processes and by the number of processors. The number of processors are 3 and the waiting times are 0, 24, 27. That means 0 plus 24 plus 27 by 3, the value is 51 by 3, the final value is 17 milliseconds. This is example for the first come first serve. And next example for shortest job first scheduling. In this the shortest job HJF, the two types are there, primitive and non-primitive. Two types of examples are there. In this HJF, we are introducing a new field. The field is arrival time. Previously, the process and burst time two fields are there, but in HJ, arrival time is introduced. It is the arrival time is a difference between the primitive and non-primitive. If the problem is primitive or non-primitive, it can decide the arrival time. So first one, we started the primitive. In the primitive means the first process always started with the P1, that means the first come first serve. Then primitive means forcibly removed, that means it can remove from process when the based on the arrival time and short job first scheduling. So because first of all at the 0 position the P2 is not available and P3 not available and P4 not available. Only the P1 is available. That's why the process P1 was started. Then after completed of the 1 milliseconds, the P2 also available and the P2 value is compared to the P1, his value is least. That means shortest value. So that's why the P1 was removed from the process and the started the P2 process. So that means P1 and started the P2, and then the P2 is completed at burst time means the completion of time. The 1 plus 4, the value is 5. And then next one at the position, that means the value is 5 milliseconds. 5 milliseconds, P1, P2, P3, P4, 4 processors are available, and the P4, the least value compared to the 3 values, P2 was completed at 4 milliseconds, so that's why it was completed. The remainings are P3, P4, P1. The least value is P4, that's why P4 was started. The P4 burst time is 5, 5 plus 5, 10. At 10 milliseconds, P4 was completed. Then next, compared to the 2 was completed already, compared to the P1 and P3, P1 value already 1 millisecond over. The remaining process time is 7 milliseconds and P3 is 9 milliseconds. So that's why started the P1. Next, P1 was completed at 8 minus 1, 7 means 17 milliseconds, when then P1 was completed. Then next last started the P3. P3 completed at 17 plus 9, 26 milliseconds. The waiting time, how to calculate the waiting time for the individual processors. So value are like this. P1 started at 0 to 1, but it does not completed. The P2 was started at 1. The arriving time also 1 millisecond. So that's why the value is P2 is equal to 1 minus 1, and P4 similarly P4 started at 5 milliseconds, but the arriving time is 3, so 5 minus 3. Next, P1 is for example the P1 was completed. If P2, P3 are moved to left side, the P1 is taken to the right side. It was started 10 minus 1. So that means the value is already 1 completed. So the two values P2 and P4 completed at 9 milliseconds. That means already the P1 was started. So compared to the 2, so that's why we write the P1 is equal to 10 minus 1. That means if it is started compared to the, if P2 and P4 was completed, the P2, P4 was completed at 9 milliseconds. Otherwise, P1 was started at 0 to 1 and completed the started. That means P2 and P4 was completed at 10 milliseconds. Actually, the waiting time is this time only waiting. Remaining time process was started. So that's why the value, how to find the value 10 minus 1. This is the waiting time. So 10 minus 1, the P1 waiting time. Similarly, next P2 is waiting time. The arriving time is 1 and the waiting time is 1. P2 equal to 1 minus 1. Next, similarly the P3. The P3 was arrived. That means it available at 2 milliseconds, but it started at 17 milliseconds. That means the value at P3 process started at 17. So value of waiting time is nothing but 17 minus 2. Similarly, the P4 available at 3 milliseconds, but it started at 5 milliseconds. So the waiting time is 5 minus 3. The values are like value P1 equal to 9 and P2 equal to 0 and P3 equal to 15 and P4 is equal to 2. The average waiting time is nothing but the values of sum of processors by number of processors. So that's why the arriving average waiting time, the average waiting time is 9 plus 0 plus 15 plus 2 by 4. Then the average waiting time 26 by 4 and the value is 6.5 milliseconds. This is the permitted. In the non-permitted, the value is slightly different because the arriving P1 was arrived at 0 seconds, available at 0 seconds, but he cannot stop it when completed of the P1. That means in the previous situation, when at arriving time 1 it can compare it, but in a non-primitive cannot remove forcibly. That means when it was started, when completed of the P1, then next go to the P2. So that's why the value is 0 to 8. And next started the P2 and next started completed the P2 at 12 and next started the P4 because those are the shortest values, and next completed the 17 and next started the P3 and completed at 26. Difference is P1 was completed in non-primitive, and in the primitive situation P1 was not completed compared to the arriving time. Then similarly the value is P1 is equal to the started at 0 and completed at 8, because in non-primitive cannot remove by forcibly. Then next P2 equal to 8 minus 1, because it available P2 is available at 1 millisecond, and similarly the P3 is available at 2 milliseconds and P4 available at 3 milliseconds. Then the process was started 8 minus 1, 12 minus 3 and 17 minus 2. Then P1 is equal to 0 and P2 equal to 7, the P3 is equal to 15 and P4 is equal to 9. The average waiting time is calculate the P1, P2, P3, P4 by 4. Then value is equal to 0 plus 7 plus 15 by 9 by 4. The value is 31 by 4 and the last value is 7.75 milliseconds. The previous value is 6.5 for permitted, and non-permitted is equal to 7.75 milliseconds. Those are the difference permitted and non-permitted HJF. And next one is priority scheduling. In this fields are slightly changed. The arriving time was changed as a priority, and the bus time and processors are same in the fields. The processors are P1, P2, P3, P4, P5, and the bus time is when completed, it was taken to completed time is bus time. P1 it completed 10 milliseconds, and P2 is completed at 1 milliseconds. P3 completed at 2 milliseconds. P4 is completed at 1 millisecond, and P5 completed at take as a 5 milliseconds. Priority means the first one is a number indicate the first taken into the process, and next one is second was taken into the next process, and third one priority is taken as a third and fourth and five similarly. See in the diagram, if P2 was number is P2 is priority is 1, so that's why in this schedule priority we cannot taken as a arriving time, we cannot calculate them, only based on the priority. If priority is 1 and it can started as a 1, and the process is started at 0 and completed at 1 bus time. So when bus time is 1, that means it completed at 1 milliseconds, and next one second one is a number as priority is 2, so that's why P5 was started at completed up the P1. Then the time is bus time is 5, so that's why the value is 6. And next P1 was started because the priority is 3, 1, 2, 3, then completed at 10 milliseconds, already started at 6. Next added the 10, the completion of the P1 at 16 milliseconds. Then next the value is after 4 is P3. P3 was started at when I completed up the P1, P3 started. P3 value is 2, 16 plus 2, the value is 18. When 18 milliseconds P3 was completed, and next the value is started after P3, the value is started P4 last one. The value is the burst time when I completed the P4 process at 1 millisecond, then the value is 18 plus 1, the value is 19. Then first one, the waiting time is for P2 is not wait, P2 was started at 0, so that's why the value is 0, and the P5 waiting time is 1, and the P6 is 6, P1 is 6, and the P3 is 16, the P4 is 18. So the average waiting time to calculate the P1, P2, P3, P4 by 5. So the average waiting time is 0 plus 1 plus 6 plus 16 plus 18 by 5. So the value is 8.2 milliseconds. This is the 5 value. And next one, round robin scheduling. The round robin scheduling is like a first come first serve, but it is depends on the quantum. Quantum means the unit is, for example, in this process we take as a quanta is 4. That means the process is like a shift wise. The shift is converted into the 4 milliseconds, 4 milliseconds, 4 milliseconds. So in the process, first one first come, same as it can started, but it can stopped when a quanta is completed. So see in the example. So first one, the first was started, the P1 was started at 0 milliseconds. When after the 4 milliseconds, it can be forcibly stopped and start the next process. That means the P1 next process is P2. P2 also stopped at 4 milliseconds, but the P2 completed at 3 milliseconds. That means when you are stopped the P2 process, they already completed. So the already completed P2 process when at 7 milliseconds. Then next the 7 milliseconds started P3, and the completed is the quanta time is 4, but it early completed with early completed of 1 milliseconds. The value is 7 plus 3, value is 10. Then next again the P1 was started. That means one cycle is completed, then again was started. The quanta is nothing but the pack of the milliseconds. We can consider as in this example 4 millisecond is a quanta. Then next started as a P1. P1 was started, already completed the 4, then started 10 plus 4, 14, and next one already check the this next position and next position. The processors are already completed, so that's why only single processor there, P1. Then next pack is continue. The pack is 14 to 18. Then next pack is continue 18 to 22. Then next pack is continue 22 to 26, and then next pack is continue 26 plus 4, value is 30. The processor was completed because this value is total bus time was 30. Then we taken as example P1, P2, P3, P4, total value also 30. So the P1 process was completed because already these values are 10 to 30, value is 20, and already the first P1 was completed at 4. So that's why the total value is 24 bus time was completed. Then next, the average waiting time, we can calculate the average waiting time. First of all, already in the previous example we see the shortest job. This is the value because this is a waiting time. So that's why 10 minus 4. In the previous example we taken as a 10 minus 1, the value is 9. So similarly we taken as a waiting time P1 equal to 10 minus 4, and next P2 equal to it started at 4 milliseconds. So that's why it can wait up to 4 milliseconds. The next P3 was started at 7 milliseconds. That means it wait 7 milliseconds up to. Then average waiting time is P1 plus P2 plus P3 by 3. Then the value is 6 plus 4 plus 7 by 3. The value is 17 by 3. So value is 5.66 milliseconds. These are the CPU scheduling algorithms. If you can like the video and share and subscribe, thank you for the watching.